Assalamualaikum and hello everyone. My name is Kairunisa Nufaiza binti Muhammad Karol Faris and I'm from EE521 In this video, I will discuss and explain about our first lab for ECE521 for microprocessor subject. Are you ready? Let's go! For the first question, students are required to write a program to move the 8-bit hex number of 76 to the register R2. Here is the program. The move instruction, which is represented by MOV, is used to copy the data into register or from the register to the register. So with the immediate addressing mode, the R2 has been addressed with 76 of 8-bit hex number. The left side is recorded as the result after executed. For the second question, the 32-bit hex number are needed to load in the register R2. As for the program, since the questions required students to load data into the register, the LDR instruction is used to immediate the 32-bit of data put into the register R2. The result at the register window shows that the data is written into the register. For the third question, students are required to write a program to store a memory location with 16-bit hex number AB12. Here, the STR instruction must be used, but first, the specified address must be loaded into the any register, which is I use the register R2 by using LDR instruction. Then, the 16-bit hex number is copied to the another register that is R3. Since the hex number is 16-bit, the instruction must be MOV-T or MOV-W, but here I use MOV-W instruction. Next, the STR instruction is used to store the content in the register R3 into the memory location of the R2, or in the other words, the memory of R2, and the indirect addressing mode is used. After execute the program, the result is shown in the memory window, and it shown that the 16-bit hex data is stored in the memory of R2. For the next question, the 16-bit hex number 89CC need to be loaded in the register R5, where the 16-bit number comes from the specified memory location. First, the MOV-W instruction is used to move the 16-bit data into any register where I use R2, when the specified memory location is loaded into the R3 by using LDR instruction. Next, the STR instruction is used to store the content in the register R2 into the R3 memory. Lastly, the value in the address R3 is loaded into the register R5 by LDR instruction. The result shows that the R2 and R3 have been addressed as required in the register window. In the memory window, it shows that the data of register R2 is now stored at memory R3. Lastly, the data in the memory R3 is now loaded into the register R5. Next, students required to write a program to add 32-bit hex number. For the program, the register of R2 and R3 is loaded with the different 32-bit hex number by using LDR instructions. Next, the add instruction is used to perform the addition operation between R2 and R3 and load the answer into the next register R4. As you can see, in the register window, the additional answer that is BBDE0021 is in the register R4. For the sixth question, the question asks for the operation of R2 equals to R1 minus the hex number 0034AABC to be performed. Let's see the program. The given 32-bit hex number is loaded into the register R3 and other random 32-bit hex number is loaded into another register R1. Then, The subtraction operation between R1 and R3 is performed by using sub instruction. The answer of the subtraction operation will load into the register R2. So, the result of the subtraction now is shown at the register R2, that is AA812221. Next, the question asks the student to write a program to multiply these two 16-bit hex number, which is 6398 with 1 DFE. Same as before, the 16-bit hex number is moved to the registers by using MOV-W instruction. Hex number 6398 and 1 DFE are moved into the R2 and R3 respectively. Then, for the multiplication operation between R2 and R3, the mul instruction is used. After execute the program, the data in the register R2 and R3 are multiplied and load the answer into the register R4 as shown in the register window. For the 8th question, students are required to write a program to OR data in R3 with 8-bit hex number 10 and store the answer in the register R5. In the question, OR from the bitwise instructions must be used. Firstly, a random 8-bit hex number is moved to the register R3, where I use the hex number 01 for R3. Then, the OR instruction is used to OR the R3 with the hex number 10, and then the answer will load to the register R4. After that, the content in the R4 will store in the register R5 as required from the questions. The result in the register window shows that the 8-bit hex number 11 in the register R4, and the memory window shows the value of 8-bit hex number 11 in the memory R5. This result is obtained when the 1 in R3 OR with the 0 will get 1, and the 0 in the R3 OR with the 1 will get also 1. For the last question, students need to write a program to compare number 5 with the register R2. If the number greater than 5, the answer will store in the specified memory location, that is 4002000. Otherwise, the number will add with 1. For this question, there are two results, which are when R2 less than R1 and when R2 larger than R1. First, I will explain about when R2 less than R1. The number 5 has been moved into the register R1 and a smaller number moved into the register R2. For example, number 3 by using move instruction. Then, the given 32-bit number is loaded into the register R3 by LDR instruction. Here, the compare instruction must be used to compare two operands and changes the flags according to the result of the comparison. The BHI and B is a type of branch. BHI is a conditional branch and B is an unconditional branch. This branch is used to jump the program to the line that has the same name as the branch. For this program, since R2 is smaller than R1, the branch BHI is not executed after run the program. This is because the BHI is a condition branch where the value of R2 must be larger than R1 after compare. So, the program will skip and execute the add line so that the R2 will add with 1. After that, the program will execute the unconditional branch B to jump the program to the no operation instruction NOP. As the result, the R2 will add by 1 and load into the register R2. Lastly, for R2 larger than R1, the number 6 is moved into the register R2. Since R2 is larger than R1, the branch BHI is executed after run the program. This is because the BHI is a condition branch where the value of R2 must be larger than R1 after compare. So the program will skip the add and B line and then execute the str line so that the content in R2 will store in the memory R3 until the program execute the no operation NOP instruction. As for the result, the value of 6 is shown in the R3 memory in the memory window.